In the last videos that I recorded, we were learning about variables, and we came to understand that a variable is a name for a place in the computer's memory where we want the computer to remember a value. That we store a value at a variable by using an assignment statement like this thing you see here. And then we can retrieve the value of the variable by using it as an expression, and that the key that tells us we want to use a variable is whenever we want our program to remember something. And so far the only kind of Actually, I should point out, not only do we learn how to assign to a variable, but we learned that Java requires us to declare a variable before we use it by saying the type and the name of the variable somewhere beforehand. And so we saw that, for example, we could declare x will store a Boolean value. And this code doesn't actually do anything so much as alert the compiler that, yes, we intend to store a Boolean value in x. And then at some point later, we can assign it looks like we assigned true to x, and then we changed the value of x to be not x, right? X gets the value of not x. Remember, equals is pronounced gets the value of in my recommendation. And the variable dies at the closing brace. But the only kind of variable we've seen so far is a Boolean, and it turns out we're going to spend a great amount of time working with Java where our variables are more than just true-false values, and one of the types that we're going to use the most often is the integer type that will let us store integer numeric values. Most of the time when we want to deal with numbers in our computer programs, we'll probably use integers. So let's start playing with integers. And let's see. Alright, so I'm going to write a little program that uses integers. In fact, maybe we'll just play around on Dr. Java first. So let's see. So if I write int x, I'm declaring that x will one day store an integer. And then we can assign a value to x, like I can say x gets the value of 3, and then we can declare another variable y, and we can say y should store the value of x. We can, in x, we can say x should store, and we can use all sorts of arithmetic on integers, so we could say x gets the value of x plus 1. And although this might make your math teacher blow up, x equals x plus 1, in Java, equals doesn't mean equals, it means gets the value of, so x is going to get the value of x plus 1. The value of x is 3, 3 plus 1 is 4, so x gets the value 4. And when we do that, x is now 4, and y is still 3, right, because we stored the value of x in y when x was 3. Let's look at a different example. Suppose, here we go, let's just do this one hypothetically on my little blackboard here. Suppose we say int n. So I declare a variable called n, which will one day store an integer, and that day is today. So we'll say n equals 0, and we'll say while n, and now I'm going to show you that our Boolean tests. So actually, let's see, I think in the example you just saw, you learned that we can add integers. That shouldn't surprise us. Not only can we add integers, we can subtract them, we can multiply them, we can, in fact, let's go through some of those operations before we get too bogged down in this example I was about to do. So let's do that over here. Int Operations. So one of our operations is that we can add. We could say 3 plus 4, we could say 5 minus 2, we could subtract, we can multiply, and I don't think you'll be surprised by the behavior here. 4 asterisk 5 means 4 times 5, so that expression evaluates to 20. One that's a little bit surprising maybe is if we say 7 divided by 3. Let's do that, 7 divided by 3. And you may be the sort of astute math student who says 7 divided by 3, well, let's see, that's going to be 2 1/3. So you'd expect maybe the computer to tell you it's 2 1/3 or 2.333333 like your calculator would say. But Java's actually going to say 2. So when I use this slash that means division, and I guess I should have said slash means division, when I use that in Java, I'm actually asking for Java to perform integer division. How many times does 3 go in evenly into 7 with nothing left over? And the answer is 3 goes in twice, but there'll still be 1 left over. If I want to know how much is left over if I were to divide 7 by 3, then instead of saying 7 divided by 3, I'm going to say 7 mod 3. And what I did is I typed a percent sign, but I pronounce it as mod, or short for modulo. 7 mod 3, which in English basically means what is the remainder when you divide 7 by 3? and the remainder is 1, right? 3 goes in twice with 1 left over. So let's make a note of that. So 7 divided by 3, that answer ended up being 2, because that's how many times 3 goes into 7 without splitting it up into little pieces. And 7% 3 gives us 1, because the remainder, when we divide 7 by 3, is 1. And sometimes that percent sign is sometimes pronounced as mod in discrete mathematics. So we say 7 mod 3 equals 1. And sometimes that could be a useful trick. For example, x was a variable I think I had a moment ago, and I can say x% 2. That's the remainder when I divide by 2. If x is even, the remainder should be 0. If x is odd, the remainder should be 1, so I can find out if x was even or odd. And apparently x was even. And since I guess x is 4, so 4 is even. Right. So sometimes I can use that to test if a number is divisible by something or is even or what have you. But not only do I have these sort of basic arithmetic operations, but I also have comparison operations. So we can say, is 7 greater than 3? And if I ask Java, is 7 greater than 3, Java tells me, oh, I should point out, that first greater than sign is the prompt. The second greater than sign is an actual greater than sign. So I'm testing, is 7 greater than 3? And the answer is true. So the answer here is a Boolean. So these are operations where I have an integer and another integer and some operation, and what I get back is a Boolean, a true or false. So that includes 7 greater than 3 or 7 less than 3. That should be false. 7's not less than 3. Or 5 greater than or equal to 5. And this is how I draw greater than or equal to. A greater than followed by an equal, just like I pronounce it. And 5 is greater than or equal to 5. Or 4 less than or equal to 3. 4 is not less than or equal to 3, so that would be false. I don't know if we've seen these before, but we can say 5 equals 2. That would be, maybe we haven't seen this before. I should point this out. So equals is testing if two things are equivalent. So if I say 5 equals 3, I'm saying, are those the same value? And the answer is false. They're not. Whereas 5 does equal 5. On the other hand, I should point out that not only can we use equals on integers, we can use it on all sorts of things. We can ask, is true equal to true? Is, I guess I can load my little robot world to convince you of this. Here we go. There's my robot world. And we can ask, is robot on dark equal to robot front is clear? Let's see. On dark is false. Front is clear is true. False does not equal true, so this expression should evaluate to be false, right? If I simply say false equals true, that's false. On the other hand, I can say, is it not the case that false equals true? That's true. And another way I can write that in Java is, does false, is it not equal to? So exclamation point equal sign tests not equal to. Is false not equal to true? Yeah, false is not equal to true. Just like 3 is not equal to 4. So those are comparisons we can use on integers, but also on, Boolean values and all sorts of other things. So 5 not equal to 2, and that would be true. I'm running out of room here. All right, so that gives a sense of the sort of basic operations we might perform working with integers, and we see that some of those give us another integer, and other operations give us back true or false, a Boolean value. And I want to go all the way back to what I was going to do originally. While n is, now I can use any Boolean condition, so this could be something like while robot on dark, as we've been doing, but it could also be while n is greater than 0. Right? That's a Boolean test. And we can say n gets the value of n plus 1. So this is a funny bit of code, and I want to figure out what it does. So the first thing that Java's going to do is, let's draw Java. Here's Java, and Java has some feet here so it can do jumping jacks or something. And when I run this code, Java will be thinking about n. And that's not an n, that's an h. Here we go, n. And Java will be thinking that n is 0. And I guess when I say that, I'm assuming this line is already executed. We've initialized n to be 0. We've assigned n to be 0. And then we ask, is n greater than 0? No, right? 0 is not greater than 0. So we won't enter this loop, and we exit right away, which is actually too bad because that's not the example I want to illustrate here. Let's do one. Oh man, where's my cursor? There it is. Let's start n at 1. Let's have some fun here. What if n starts out at 1? Is 1 greater than 0? Yes, true. So we enter the loop, and n gets the value of n plus 1. n is 1. n is 1. So the value of n plus 1 is 2. n gets the value of 2, so n becomes 2. Java's thinking that n is 2. And then is 2 greater than 0? Yes. So we enter the loop again, n gets the value of n plus 1. That increments n to become 3, and then 4, and then 5, and then so on. What is this loop going to do? What does this loop do? It looks like it's just going to count up forever, which is maybe not a very useful thing to do. But it turns out it doesn't count up forever, which is actually very surprising when you think about it. So one more thing I need to tell you about integers is that there is a limit to how high an integer value can be in Java. Not all languages have this limit, but in Java there is a limit, and the limit is, it happens to be, I believe precisely, 2 to the 31st power minus 1 is the maximum integer. And by the way, when I write this, I'm using this in a math sense. You can't actually write 2 caret 31 in Java, although many a student has tried, so maybe we'll just actually write that like this. There we go, 2 to the 31st minus 1. You shouldn't know that, at least not yet not at this point. I think the main thing to know is that there is a limit on how high an integer can be, and that roughly speaking, ints range from negative 2 billion to positive 2 billion. And it's not precisely negative 2 billion, and it's not precisely positive 2 billion, but if you keep your integers in that range, you'll be safe. So sometimes you want to, most times we're not going to deal with numbers higher than 2 billion, but if we do deal with numbers higher than 2 billion, then we're going to have to extend what we know about Java. We might start using something called a long, which is like an integer, but has more memory and therefore can keep track of more digits, and there may be other data types built into Java that we could use. But for now, int means an integer that ranges from a low value of about negative 2 billion and a positive value of a little higher than positive 2 billion. Alright, I'll see you in the next video when we'll start putting these integer values to use in solving some problems.